How you doing? So this talk is for developers, and I guess that most of you probably aren't developers. How many people do I have in the room who check out code in the morning, check it in at night? Come on, it's not after lunch. So I've only got like 10, maybe. Okay, most of you are InfoSec people. So what we're going to do is we're going to make a slight modification to the talk to focus a little bit more on what you need to tell your developers. Does that make sense? That's what we're going to do. And the problem is that we're in this environment where, see, my speaker notes say, how many of you know what a pen test is? I'm figuring probably pretty much everybody here knows that. But, so the problem that we're talking about here is that developers are in a position where they're having to take applications that were written for, servers they have in their basement, or under their desk maybe, and moving them to cloud providers. And the security profile, as you all well know, is very different between servers you can put your hands on and servers that are locked in an armed cage in Ireland or whatever. It's a very different world. And you have to do different things with regards to your application development process if you want to make that work. That is what this talk is all about, is the changes you need to make that work the way you want it to work. But first, a little bit about me. My name is Bill Sempf. I've been in application development for the internet since before there was a web. I know Gopher script. I'm currently working primarily as a vulnerability analyst because I was the security guy on the dev team for years and years. You see, back in 1997, I was building web applications for a small ISP in Grove City, and on a Saturday afternoon at 2 o'clock or something, the server paged me because its hard drive was full. Well, there's no possible way that that was the case. So I went to log into it and couldn't because the hard drive was full, which tells you how full the hard drive was. So I got in my car and drove over, something else we can't do in the cloud, right? Drove over, got on the terminal, logged in, and found out that the entire hard drive was full of German porn. The reason was because there was a SQL injection flaw on one of the applications I had hosted on that machine. At the time, I had no idea what SQL injection was. Keep in mind, this is before OWASP. This is well before the pen test execution standard. This is well before application vulnerability analysis was really even a thing. No one was checking for this stuff, which is why it became such a big problem. Well, because it happened to one of my applications, I decided I was going to make sure that did not happen again. So I got to learning about it. And as it turns out, however many years later, it actually became something that was important. So that's what I'm spending most of my time doing these days, is checking web applications for vulnerabilities and then using my experience as an enterprise dev, teaching the developers how to fix those problems, which is exactly what we're going to talk about here today. We're just going to talk about it in the cloud. Other things, I'm from Columbus. Probably most of you have heard me talk before because I'm at a lot of these cons. My family's not here wandering around like they normally would be if I was out of town. But a funny story, a close friend of mine just graduated from the Columbus Police Academy last year. So I was here we're sitting where you're sitting, watching graduate, and also here for the family day, halfway through the thing. And so if a uniformed police officer walks in at some point, that's not because he's taking me away, probably. Anyway, so that's where we're at. I'm a Microsoft MVP for developer security, but so you'll see a lot of Azure stuff in this. But this isn't an Azure specific talk. We'll talk a little bit about Azure tools, but there's tools for any cloud platform you choose to use, including tools that are very generic in use. So that's okay. And what other stories do I like to tell here? I don't know. That's probably enough, but a lot of you know me anyway, so. So the whole reason this came about was because of a talk that Brian Prince used to give. Now, Brian Prince was, for quite a while, some senior executive with the Azure team at Microsoft. And he would give this talk that was basically to try to encourage server huggers to give up their hardware and to move to Azure. So it was let me assuage all your feelings of woe, and convince you that hosting on Azure is going to be better than hosting on a server in your basement. So a lot of the common myths about cloud computing he would dispel in the talk. But a big part of the topic was security. And he would show pictures of the big facility in Seattle with armed guards out front and all of this stuff, and talk about their update routines and how, hey, you can't get much better than hosting with someplace that's driven by the operating systems are primarily written by the company who's hosting the machines, right? Obviously, they're going to have the latest version of Windows Server if Microsoft owns the boxes. And the general consensus was it's more secure, not less, more secure to host on a server you can't see or touch than it is to host on a server that's in your basement. There is some truth to that. There really is. I mean, you are not going to have somebody sneak into the Azure facility and plug a LAN turtle into the back of one of those servers. It's just not going to happen, right? Whereas it's possible that it's going to happen in your facility. I mean, even I've done it. I am not a pen tester. So that's there's a grain of truth there. It's more than a grain. There's a significant modicum of truth there. However, it doesn't change the core fact that the applications that you're hosting on those servers are not any more or less secure than they were before you hosted them there. For one thing, any vulnerabilities that you find in a web application will still be vulnerabilities hosted on Azure. And two, there is a different threat model when you're hosting on Azure than there is when you're hosting on your own server. So that's what we're going to dig into. Let me give you a quick example. Oh, wait. Well, let me see here. Okay, so it's not running yet. So don't worry about this yet, because it's going to be a movie in a second. One more quick story about the hosting piece, right? The Onion router, Tor, right? Hidden services on Tor. Super secure, right? No. Same problem that cloud computing has. That's how they keep catching all the baddies who are supposedly using Tor to do things you shouldn't do, is because if you put PHBB 421 up on a Tor hidden service, it's going to be just as insecure as it would be if you hosted it on a server in your basement. All the same authentication flaws are there, all the same injection flaws are there, all the same session management flaws are there. Everything is still just as insecure as it was before. So this is my, please work. Oh, good. So this is my content management system. It is fantastic. And as you can see, it's very safely hosted on Azure. Now, you might not be able to see, but it says cloudapp.net up there. So you can put in your name, and it says, welcome. Fantastic, yeah? I think so too. So, even though it's hosted on Azure, though, and it's obviously, well, it's not obviously, but it happens to be written in ASP.NET, certainly you can't do something as brazen as just type an image tag with JavaScript in it, could you? That couldn't possibly work, because it's hosted on Azure. I mean, surely we're not going to have a problem with that, are we? Yeah, of course we are. Why? Cross-site scripting has nothing at all to do with the server you're hosted on. Nothing at all. You can, in the application, turn off the cross-site scripting protection in ASP.NET up in the body, up in the form tag, the page tag, just like you can if you're hosting the server under your desk. And I'll tell you what, they do. They do constantly. You want to know why they do, just out of curiosity? Is because if you if you run into a problem where you have to accept text that looks like it might be an attack, and then you get this really ugly yellow screen of death back in your development environment. And if you search for the error message that's returned, the first 45 results that come back from Google Bing are, hey, here's how you turn off the safety protocol so that this doesn't happen again. And people can type anything they want in there. Guaranteed, if you run ASP.NET, you have at least one application out there that has it turned off. I know because I've turned it off on several of them, and I've probably worked for your companies before. So, there's no cookies. Of course there's no cookies yet. So the point here is that the fact that they're running the most up-to-date version of IIS, and they're running the most up-to-date version of ASP.NET, and they're running the most up-to-date version of Windows Server. Yeah, I know, I've got a bottle of water in here, I'm sorry. I know there's signs everywhere that says don't do that, but I'm going to get in trouble. Even though you do all that, you're still going to be in a position where the application code itself has the same vulnerabilities, whether it's hosted locally or hosted in the cloud. So where do we start? Well, we're going to start with a couple of security principles. Okay? So these are the things that we need to work through with our developers on. Teach our devs. That's what we're going to do. So the first one is defense in depth. Defense in depth has all kinds of benefits, all kinds of uses in the security world. But in application security, it's particularly useful. The one biggest example that I get that you've probably heard before is, oh, I don't care about the injection vulnerability in the login page of this application because it's behind the firewall. So, nobody can attack it. Well, in this room, as we all know, that is absolutely not the case. It's sometimes trivial, and also we've blurred the boundaries of network security so much, which with, your own devices and, cloud computing itself, IoT, all of this, that we've stretched the boundaries of our company out so far, our corporate network out so far, it's almost impossible to protect the boundary of our network. I mean, hosting in the cloud itself is pushing the boundary of our network security. Absolutely. So, layering your security in an application is key to defending against attacks, no matter where it is, whether it's hosted in Azure or it's hosted locally. The example that I tend to give developers is, developers will, especially in today's day and age where JavaScript is a key language for the web, and with good reason, the browsers are very, very useful. So, developers will tend to write, code in JavaScript in the browser to implement security. For instance, making sure that this field only has numbers in it. Well, in order to do that, they'll just put JavaScript in there that prevents you from putting any other value in other than a number. Of course, us in this room all know that the attacker isn't using the browser anyway to do that attack. They're using an attack proxy or a script, right? So, what you need to do is make sure that that same check is also at the controller level. But that might not be good enough either, because if you have multiple applications using the same data model, then the next person who comes in to write their own controller, they might not do that. So you also should have approximately the same check at the data model level, which it should be doing anyway, because you should be using an ORM, but that's neither here nor there. The fact is that making those checks on multiple layers dramatically increases the security of the application without dramatically increasing the complexity of the application. A positive security model states that you should only allow in what is expected and reject all else. Okay? A whitelist. Instead of a blacklist, which is blocking things that you know are bad and allowing anything else into your system. Alright? So, for instance, if you have a drop-down of states, right? It's not enough to have some filter or some content security policy that says, hey, if you see these particular words, then don't allow that in. Don't allow that application, don't allow that input into our system. What you should instead do is say, if the input from this field is not on this known list of 50 items, do not allow it in. Just reject the entire request ad hoc. What's more, you should also log that feature, or that request, because we know it's an attack, right? Obviously, we're not using the web browser to make that request. Fail securely is a key aspect of secure coding, especially in the wonderful world of authentication and authorization. So failing securely, generally when I'm in a room full of devs, we get in a long conversation about exception management, right? Try, catch, finally. I won't bore you all with that conversation. But what I will tell you is that if applications are in a place where they create a user object before they check the authorization model, or even before they check to make sure that the password is correct, for instance, then there is a strong chance that that session that was created for that user is still valid within the system. And some trickery, for instance, if there's a session fixation flaw, or the session tokens aren't sufficiently random, then we could still use that session to be part of the user, just bypassing the login page once we have that strangely now still active session. And then force browse to a page that we know exists inside the application. So there's an example where the developer didn't fail securely. In that case, when the login failed, immediately should have just deleted that entire session and started over, or even better, never created it in the first place, right? So failing securely, key principle to software development. Principle of least privilege has all kinds of use in software development, and it does apply a lot to the wonderful world of cloud. When you create something that has access to your application, or create an instance of something that should be presented with some kind of access control, instead of starting with all the privileges and then retreating back to what little you need for that instance, you should start with no privilege and then add them as they go. The best example of this that I can think of for cloud is the S3 buckets. If you go out and spin up an S3 bucket, it is initially open to the world, and you have to go tell it not to. An example that probably many of you are familiar with is way back in the NT4 days, when you created a new user, it was immediately put in the domain admins group. Okay? That is the opposite of the principle of least privilege. So when you create something new within an application, it starts with no privileges, and the application should add the privileges that it needs. Separation of duties, the one good example I like to use for this is in the software development lifecycle. Matters even more when dealing with cloud computing. So separation of duties states that, well, let's use the software development lifecycle example, right? Developers develop, QA tests, DevOps deploys, and there's no branching between them. QA should not be able to check in code to the repo, right? DevOps should not be able to check in code to the repo. Even more importantly, developers should not be allowed to touch production. So even more important when dealing with cloud, because, and we'll talk about this a little bit later, you're probably dealing with an environment where you don't have a, maybe not complete control, maybe not complete understanding of what the authorization model is in the cloud. Whereas if you're dealing with your local machine, you let the operating system do most of the work. So separation of duties, key piece. Security by obscurity is an anti-pattern, okay? We don't want to try and hide things. This is very powerful. Jared's talk, he was talking about WP and min, right? There's no way you can hide that from me. I'm going to go checking for it, right? You need to assure that the authorization model is in place for that. You cannot just assume that someone isn't going to find it somehow. That isn't going to happen. I'm going to find it. I'm going to check. I'm going to look for it. Even more key in cloud, because now we have all of these administration features that we don't necessarily have complete control over. There might be some other part of our organization that controls it, or it might not be immediately obvious how to do authorization for that piece. So making sure that anything that is in production space is properly set up with access control is an absolute key piece to this puzzle as well. And finally, complexity is the enemy of security. Probably the most relevant to cloud computing, because you can create such impossibly complicated network structures and access control structures using the Azure tools and the AWS tools that you never would have bothered with in the world of server hugging. You know, if you had your own machines in the basement. And the more of that you do, the more apt it is that there will be some security vulnerability discovered over time. Remember, you're probably not going to be running that infrastructure forever and ever as long as it lasts. Someone will have to take over from you, and they will have to learn what it is that you created and keep it secure as things change over time. All right? So keeping things as simple as possible, but no simpler, is very important. And finally, and we talked about this on that first little demo, do not trust the client. Anything that moves from the browser to the server can be modified by an attacker. Full stop. There's nothing else you need to know. So using things like your host header or the user agent and making business decisions based on them can only be done if you're using input validation and a positive security model. Every single time you use something, anything in that request, it absolutely must be validated. So those principles are part of the OWASP Security Principles Project. OWASP is an international organization devised to bring security knowledge to developers. If you're not familiar with it, strongly recommend you get that way. OWASP.org is the big wiki where we store everything. I happen to be one of the chapter leaders of the Columbus chapter of OWASP. We meet around town once a month. We're on meetup.com. Get your devs to come. You can come too. You're more than welcome. Love to have you. But we want your devs to come because that's who we're teaching. We're teaching the developers these principles and more. All right, so we need to make changes to our software development lifecycle that apply to cloud computing. Some of it's like the principles, some of it's crossover. Some of it isn't. So there's new things that have to be dealt with. So we're going to talk in broad strokes. We're going to talk about planning an application and what needs to go into from that perspective. We need to talk about development itself, the actual work we need to do. And then we need to talk about the maintenance. What do we do as we keep the application running over time? So planning, consists of conceptualizing an app, scope, requirements, design, all those pieces. That's what we're talking about. Some of you do lots of paperwork. Some of you write little cards. I don't care. The fact is that no matter how you look at it, very much like herding cats. Software development planning is a pain. You have business requirements on one side. You've got the developers and the technology requirements on the other. And then you've got compliance somewhere in the middle. And it's always going to be a rat race. And now the servers aren't even in your building. So what you going to do? So we're going to start out with requirements gathering. And the key to requirements gathering in the world of cloud computing, and actually software development in general, is that security features rarely get their own requirements. There are some that do, and there's some that don't. You need to make sure that the ones that don't get looked at a little bit more carefully. So take a quick look at some of the ones that do, right? Authentication and authorization usually get requirements. If you can't log into the app, you can't use it. Encryption is often handled by, is often something that we have to look at for compliance. So that often will get its own requirements. Exception handling has been a non-functional requirements of every application document for 20 years because we figured out quite a while ago that if you don't plan for it ahead of time, you get in trouble real quick. And then, of course, data access is another non-functional requirement that usually gets its own requirements section because we don't often, as developers, we don't often have control over our own data sources. So we've got to write down how we're going to get to them, right? So these pieces are all generally speaking, are going to have their own requirements pieces. But then there's a lot of things that don't. And they're key, okay? Encoding, output encoding. Anytime you send anything to a parser, it must be encoded. Obviously, the biggest example of that is when you send to a browser, right? An HTML parser. Output encoding is the one way to prevent cross-site scripting. But very rarely is encoding built into the software security requirements of an application. Most often, developers will just lean on their platform for that. Well, they might not have complete control of their platform anymore if they're working in a cloud environment. Input validation is another. Obviously, we talked about the positive security model. That's going to be true in applications, cloud or not, doesn't matter. But it rarely gets its own requirements section, and it should. Session management, big, and cross-site request forgery on top of that, because that's part of the session piece. When you move into a cloud environment, you're often using some kind of federated identity. And very often, session management is a black box to the developers. So they're just going to say, well, we're going to use whatever comes with the platform we're working on. That's fine. In fact, it's recommended. But you need to make absolutely certain you know what you're doing, because it's probably not what you're used to. It probably doesn't work exactly the same way as they want. So they're going to need some help to make sure that they are making the right decisions as far as session management is concerned. Fortunately for us, there's yet another OWASP project that would be of great help here. It's called the Application Security Verification Standard, or ASVS. What it was originally designed for was, this is a better slide for that, actually. What it was originally designed for was certification of applications. So what it is it's 17 verticals that relate to the main core pieces of application security, like encryption and session management and output encoding. And then there's 4 levels of each with all of their requirements listed. Okay? The goal was that an application, like a tool vendor, could say, hey, we're ASVS level 3 in authentication, and you'd know exactly what that meant, and it's verifiable. They can be audited and check to make sure that they actually do meet those requirements, so they can have an audited statement stating where they are. But forget about all that for the moment. What it's actually useful for you is it's a big 60-page software, non-functional software requirements document for your applications, cloud-based or not, honestly. But specifically for cloud in this case, that will list the key pieces that need to be in those requirement slots that we talked about a couple slides back. And of course, OWASP project, so free like beer, right? Free like free beer, not like normal, you know what I mean, right? Okay. Definitely something that you should roll towards your developers as they are building requirements to either migrate to the cloud or building new applications to the cloud. Threat modeling is another piece that has to fit into the design, the overall design process, right? So this is a security crowd. I don't have to spend a lot of time talking about threat modeling. You guys are probably familiar with the STRIDE model. But the key to this now is we have all of this new input because we would gloss over a lot of the potential threats that we knew we had control over because we had control over the boundary of our system. Okay? So even though I know a WAF isn't a be-all and end-all of security, I'm not saying that at all, but there are times when we can say, well, this is a risk with this application, but we can control it with the WAF. So it's a lower priority concern from the developer's perspective because I have some control over it. Well, now you're hosting your stuff someplace you don't have nearly as much control as you did. So the threat model dramatically changes, but the process doesn't. We still do the same stuff. We still have to draw our picture. We still have to figure out where our boundary is. And then we have to list the elements of our application and then go through and categorize them with questions, right? Go in and dig through what applies to what, write them down, and then prioritize them. And that gives us an idea of what requirements in the ASVS we have to apply to what parts of our application. But you can't gloss over it. Like if you've been doing it for a while and you're used to it for your internal applications, you can't just flip through because cloud is different now. You don't have control of that boundary. Third part of piece of design is the service level agreement you have with your provider. Okay? So I don't want to do that. They will give you a certain amount of protection over, for instance, denial of service attacks. Hold them to it. And you can wrap that into your threat model so you know what it is that you're faced with or not faced with in terms of once again, the threats you actually have to think about. This is like the opposing side to your WAF if you have an internal server, the server in your basement model, right? You say, well, I know I don't have to deal with that right now because at least I have this blinky light box in place that will help me with that. Well, on the other end, there's certain things you can say, okay, I don't need to deal with this right now because I've looked at my service level agreement and I know that Amazon or Microsoft or whoever is going to protect me from certain things. I don't know what those things are, because everybody's going to have a slightly different arrangement with, as far as what you're using out of the cloud platforms. But you need to know. You need to know what's in that and what your developers can use to try to make it so you're not trying to fix everything that's in your threat model. Make sense? Okay, so the development space. Generally speaking, I am a believer in polymath developers. I think that largely good developers are good developers irrespective of platform or language. It's very easy to learn a new framework. Once you get to a certain point in development skill, it's not a big deal anymore. However, if you're going to start hosting in cloud, having someone on the team at least that you can ping, at least reach out to, with experience in that cloud platform is very important. I've been on a number of projects as a dev that were migrated up to cloud providers. And you have to look up every little thing. Every little thing. Every configuration piece, every integration with whatever services that they provide for authentication or data storage or encryption. You got to look up everything. Having a consultant on site, having somebody, an expert in your company that you can get 20% of their time a week, absolutely key to cloud migration projects and to new dev as well. Very important part. So on the dev side, authentication is a key piece, and I don't really need to tell you guys what authentication is. I think you know, right? Where it's your identity plus something you know, something you have, something you are, now even something you do. And I don't need to, I don't need to, I'm sure you guys are all familiar with pass the hash attacks, but this is a fun we're running a little behind. I want you guys to actually get some lunch, so I'm not going to talk through the animation, but the devs love to watch this. They don't know this stuff exists. But what I want you to know is that the authentication obviously is the gateway in, right? But your cloud provider probably provides some authentication system that you can use, and you should. You should leverage what they've got, but you really should know what they do and don't support that you're used to. Authentication via cloud providers is very different. These single sign-on type things, federated identity, is very different from developers storing a username and a password in a table and trying to remember the salt and hash. So understanding what's provided is a key piece to all this. Also, just like any other time, second factor becomes extraordinarily important. Because, for instance, it's very likely that if you're using, say, AWS Federated Identity, it's very likely your users are using their Amazon account to log into your system. Microsoft the same way. They're using their Xbox account to log into your system. Think about that for a minute. Okay? All the issues with password sharing and everything else. You do not need to be dealing with that. So implementing some kind of multi-factor authentication is very important. It's super easy. All the cloud providers now, I gotta stop saying most, all the cloud providers offer it. So learn how to use it and use it. And of course, there's the whole single sign-on piece that I've already babbled about. But if you're not gonna integrate with your internal federated identity and you're gonna use their federated identity, you need to know what you're getting into. So dig in. That's a whole nother hour-long talk all by itself. So data protection. Data protection often does get its own requirements in dev space, but it's poorly understood, as you know. I mean, how many times have you had to have this discussion with a developer? But I base 64 encoded it. Look, it's all gobbledygook. That's not how any of this works. All the cloud providers offer some level of encrypted data storage. Use it. Don't make the devs write it. Even if they're working in .NET or Java or something that has built-in libraries to handle encryption, don't make them write it. There's no reason to. Use the built-in tools that, oh, I'm sorry, I forgot to change slides. Use the built-in tools that the cloud provider has, right? Really what it comes down to is storing things in boxes that no one else can get into. Think about it from the business side of things. That's really all we're doing. Your cloud provider offers something like that. Take advantage of it. The developers will have not built here syndrome. I get that. Trust me. I I was the first one on that train. But it's time to change that for data protection. Multi-tenancy, yes. So bad neighbors are a real problem in cloud. Even if you are, anytime you're sharing anything, you're sharing space, you're sharing authentication systems, you're sharing anything at all, you are going to run into the problem of bad neighbors. Developers are not used to protecting against that. So there are a number of things that need to be looked into to protect you from bad neighbors. Most of it can just be handled with a good, solid dose of paranoia. In general, developers like to hold hands and sing Kumbaya. Everyone's going to get along. It's going to be wonderful. This is a good time to squash that at least a little bit, because when you're in that multi-tenancy world, you gotta put up the wall and dig in. Yeah, that's enough on that. Okay, so maintenance. I still look around to make sure nobody's seeing me drink, even though I'm standing on stage. All right. So maintenance. Maintenance is a long slog, right? Team of developers left behind, brownfield development. Terrible. Working in the cloud makes it worse. So you need to plan up front for a much more significant maintenance pattern than you've had in the past. All of these services I've been telling you to use, data protection service, authentication, authorization, session management, all that stuff, when Amazon decides to change it, it's going to break your app. So you need to have a maintenance system that's and by maintenance I mean developers who are ready to make changes to the code. You gotta keep your code up to date. You gotta keep your source control alive for the length of the application. Cannot tell you how many times I've been in a position where there's something hosted on, well, anywhere really, but on Azure specifically I'm thinking of, and I say, all right, well, we're going to have to make a change because the encryption module has changed in Azure, so we need to change your code. Where is it? Oh, it's right here, and it's a bunch of DLLs. All they've got is the compiled code. Where's your source code? I don't know. Let me call the architect left. He's with, what company is he with now? Let me look on LinkedIn. I'm serious. It's terrible. You cannot let that happen. So absolutely must be prepared for the world of maintenance. So I'm going to read a passage from CIO Magazine because I could not have written it better myself. Even though you have deployed various cloud application security solutions, encryption, DLP, antivirus, anti-malware, residual risk will always remain when adopting a new cloud application. Ultimately, it is a business decision to integrate a new cloud application into the enterprise's business process. Making that decision needs to take into account whether the trade-off between the cloud application security risk profile and the business capabilities of the component are worth it. One solution is to have a task force, which includes business and IT leaders, to explore these issues. That is your solution to the maintenance problem. There needs to be a group of administration-level people who are in charge, just like your software change council. You probably can use that same group to make sure that all the T's are dotted and I's are crossed when it comes to maintenance of these applications. So data loss. I bet you think I'm talking about people stealing your data, but I'm not. What I'm talking about is accidental deletion or loss. Once again, from that same CIO article, accidental data deletion or overwriting can cause the permanent loss of data files in the same way as similar malicious behavior. Having adequate off-site backups can prevent organizations from irreparable damage caused by data loss threats. You would not believe how easy it is to accidentally delete the entire database server forever. I've seen it done. It is horrifying. It's not, oh, the database is gone. Oh, we accidentally dropped this table. Let's restore from the SQL backup. No. You deleted the entire SQL server, and it's gone. It's unspeakably bad. So this is an authorization problem and a separation of duties problem, but it's also a backups problem. When you back up your server in the basement, you have a tape drive hooked to it, or a NAS, right? In the cloud, do you trust their backup solutions? How offsite are their backups? What do they provide as part of their SLA to you? Learn that. and use it, because I guarantee you, you have not seen MAD until the entire SQL Server got deleted. Trust me. That was a long night. Incident response is probably something that I don't need to talk about very much here. If you don't have an incident response team, bad on you. I'm at a security con. You all should be dealing with incident response already. But just in case you're not, obviously, the first thing you need is that threat model. And then that's that team again, which can be the same team that's doing the maintenance stuff. They can be the same group of people. Then you need a plan, and you need to test it. Right? But that's something you guys are all good with. So, all right, so we've gone through all this. Where exactly does that leave us? So, you need to own your own deployment as much as you can. All right? So, yeah, this is okay. So this is not me doing this. This is the developer of this tool. That's why the username was funny. You lose a fair amount of control and a fair amount of insight when you start to deploy to the cloud. You can't just hang things up there and expect them to be okay. You need to stay informed as to what's happening. So this is Azurite. There are tools like this for all the cloud providers, and there are generic tools like this as well. But if you're using Azure, Azurite is fantastic. And what it's used to do is audit your entire cloud deployment from soup to nuts. Absolute requirement for you folk to be doing to help protect your developers from blowing themselves up, which they will occasionally do. I'm not going to sit and wait for the whole video to go through, but what it'll eventually show, if we get far enough along, is that what it'll do is you give it the credentials, the top level credentials for your deployment, and then it will sit and go through and get every last little hidden configurations file, every last little PowerShell script that's running under the covers, every database, every deployment, every object that's sitting in Azure, give you these well-structured JSON files and then gen reports from them that you can then give to your CIO and say, this is what we've got, and I know where all of it is, and I know what to do about it. And oh, by the way, see these 3 users here? They shouldn't be there anymore. We need to get rid of them, which takes testing. But tools like this are probably what you should go back right now and do. All the other advice is stuff that's going to take place over time, but go back right now and audit your cloud deployment and see what's going on up there. Yep. There's the pretty JSON that comes back. Really amazing what happens. My personal Azure account, it just has, I just throw stuff up there for all kinds of reasons. Man, I could not believe how much stuff this brought back for me. It was truly astonishing. So, own your own deployments and get a really good grip on what is up there and what isn't up there and what you need to add to make things better. And that's all I got, folks. You can find me on Twitter, and look me up if you need. I'll take any questions you've got now, or you can just come up here because I think we got a half-hour break. Or you can look me up online, and I'll be glad to answer any questions then. But other than that, thank you very much for having me out. I hope you have a good con.